We think our sun is unimaginably large. It could fit more than 1 million Earths inside it. But in the universe, our sun is almost insignificant. There is a star so enormous that if it replaced our sun, the inner planets would disappear, Jupiter would vanish, and even Saturn's orbit might not escape. This is Stephenson 2-18. The sun dominates our lives. It lights our skies, warms our planet, and holds every world in the solar system together through its immense gravity. Compared to Earth, it is unimaginably large. More than 1 million Earths could fit inside its volume. For most of human history, that seemed impossible to comprehend. Then astronomers began looking deeper into our galaxy. They discovered stars larger than the sun, then larger still. Red giants, supergiants, hypergiants. Each new discovery challenged our understanding of how large a star could become. Eventually, among the crowded stars near the center of the Milky Way, astronomers found one object that dwarfed nearly everything else we had ever observed. Its name was Stephenson 2-18, and suddenly, our sun no longer seems so enormous. Stephenson 2-18 is located approximately 19,000 light-years from Earth, buried deep within one of the most crowded regions of the Milky Way. It belongs to a massive stellar cluster known as Stephenson 2, where thousands of stars formed from the same giant cloud of gas and dust millions of years ago. Finding a single star inside this crowded environment is extraordinarily difficult. Interstellar dust blocks much of its visible light, making the star nearly invisible to ordinary telescopes. Only through infrared observations could astronomers finally begin to uncover its true nature. What they found was astonishing. Not simply another giant star, but one of the largest stellar objects ever identified. Stephenson 2-18 belongs to one of the rarest classes of stars ever discovered, a red hypergiant. These stars represent the final stages of stellar evolution for some of the most massive stars in the universe. After burning through enormous amounts of hydrogen over millions of years, their outer layers expand to unimaginable sizes. As they grow larger, their surfaces cool. Instead of glowing white or blue like younger, hotter stars, they radiate a deep reddish-orange light. Despite appearing cooler, red hypergiants remain incredibly luminous. Stephenson 2-18 shines with hundreds of thousands of times the luminosity of our sun. Its enormous size is not a sign of youth. It is evidence that the star is approaching the end of its life. Numbers alone cannot describe Stephenson 2-18. Its estimated radius is roughly 2,100 times larger than the radius of our sun, although the exact value remains uncertain and continues to be refined by astronomers. Trying to imagine such a star using everyday experience is almost impossible. This is no ordinary object. It is a cosmic giant existing at the very edge of what physics allows stars to become. In the next part of our journey, we will attempt something almost impossible. We will shrink the solar system into a scale our minds can understand, and place Stephenson 2-18 at its center. Only then will we begin to understand why this star has become one of the most astonishing objects ever discovered. There is only one way to truly understand the size of Stephenson 2-18. We must bring it home. Imagine removing our sun from the center of the solar system. Now place Stephenson 2-18 in exactly the same position. At first, nothing seems unusual. The star simply glows with a deep crimson light. But then, its surface continues expanding. Past Mercury, past Venus, past Earth. The oceans, continents, and atmosphere that make life possible would all disappear inside the star itself. Our entire planet would no longer orbit the sun. It would exist inside it. Suddenly, the solar system no longer feels enormous. Earth becomes nothing more than a forgotten point swallowed by a single star. The expansion doesn't stop with Earth. Mars disappears. The asteroid belt vanishes. Jupiter, the largest planet in our solar system, is consumed by the star's unimaginable radius. Even that is not enough. Current estimates suggest Stephenson 2 to 18 would extend almost to the orbit of Saturn if placed where our Sun is today. Nearly every familiar world of the inner solar system would cease to exist. Only the distant outer planets would remain beyond its glowing atmosphere. It is almost impossible to comprehend. A single star replacing nearly an entire planetary system. Not because the planets became smaller, but because the star became unimaginably larger. Light travels at nearly 300,000 kilometers per second. It circles Earth more than 7 times every second. To us, light feels instantaneous, but Stephenson 2 to 18 changes that perception. If you could stand on one side of this immense star and somehow send a beam of light toward the opposite edge, it would take hours, not seconds, to complete the journey. Even light, the fastest thing in the universe, cannot cross such an enormous distance instantly. That is the true meaning of cosmic scale. Not simply that something is large, but that even the universe's speed limit begins to feel slow. Stephenson 2 to 18 is so vast that it forces us to rethink what big actually means. The human brain evolved to understand forests, mountains, rivers, cities. Even planets challenge our imagination. Stars push it even further. Stephenson 2 to 18 exists on a scale our minds were never designed to comprehend. No photograph can truly capture it. No animation can perfectly represent it, because there is nothing in everyday life remotely comparable. And perhaps that is the most astonishing part of all. The universe contains objects so enormous that our language begins to fail. Numbers lose their meaning. Comparisons stop making sense. All we can do is stand in awe. And yet, this unimaginable giant is only one star among hundreds of billions in the Milky Way. Nothing in the universe lasts forever. Not planets, not galaxies, not even the largest stars ever discovered. Stephenson 2 to 18 may seem eternal, but in reality, it is living on borrowed time. Massive stars burn through their nuclear fuel at astonishing speeds. While smaller stars like our Sun can survive for billions of years, hypergiants consume their fuel so rapidly that their lives are measured in only a few million years. Stephenson 2 to 18 has already reached one of the final chapters of its existence. Deep inside its core, the balance between gravity and nuclear fusion is becoming increasingly unstable. For millions of years, fusion pushed outward while gravity pulled inward. One day, that balance will finally collapse. And when it does, one of the most violent events in the universe will begin. When the core of a massive star can no longer support its own weight, gravity wins. The collapse happens in seconds. Temperatures soar into the billions of degrees. The core rebounds with unimaginable force. The result is a supernova. For a brief moment, a single exploding star can outshine billions of other stars combined. Shockwaves race across space at extraordinary speeds, carrying newly forged elements into the galaxy. Iron, gold, uranium. Many of the elements that exist within your own body were created inside ancient stars that died this way billions of years before Earth was born. Death in the universe is also creation. Without exploding stars, rocky planets would never form. Oceans would never exist. Life itself would never appear. Stephenson 2 to 18 may one day become another cosmic factory, enriching the Milky Way with the ingredients for future worlds. What happens after the explosion depends on something incredibly important: mass. If enough material remains after the supernova, gravity may continue crushing the stellar core beyond the limits of matter itself. The result could be a black hole. Astronomers are still studying stars like Stephenson 2 to 18 to better understand exactly how these enormous giants end their lives. The final outcome is not yet certain, but whatever remains, It will no longer resemble the magnificent red giant we see today. The brilliant light will disappear. The vast atmosphere will be gone. And one of the largest known stars in the Milky Way will become something entirely different. Even giants cannot escape the laws of physics. Stephenson 2-18 is almost impossible to comprehend. Its diameter stretches across distances that swallow planets. Its light has traveled nearly 19,000 years before reaching Earth. Its future will reshape the space around it long after humanity is gone. And yet, it is only one star. The Milky Way contains hundreds of billions more. Across the observable universe, there are hundreds of billions of galaxies, each filled with countless stars of their own. Some are smaller. Some are hotter. Some may even prove larger than Stephenson 2-18 as astronomy continues to improve. The universe refuses to stay still. Every new telescope changes what we know. Every new discovery reminds us that today's record holder may become tomorrow's stepping stone. Perhaps that is the greatest lesson Stephenson 2-18 teaches us. Not that the universe is filled with monsters, but that reality is always larger than our imagination. The more we discover, the more we realize how little we truly know.